Hello, sir.
Hello, sir. Shall we start?
Yes, sir. Please go ahead.
Shall I go with the material?
Yes, sir.
Thank you. Friends, today we are going to have a discussion on instructional design for problem-based learning in engineering. This is a very important aspect, especially for the engineering teachers in engineering classes. We have to make our students to be ready to solve the field problem. In any instructional design, we have to bring many aspects which will make the student to take charge. They have to think about the future. When they are real engineers, they have to solve the problem. We are trying to provide that opportunity in the program itself. Let us see the engineering students. They are all very smart, capable of solving the problem. They are all very much interested. We have to motivate them to solve the real problem. In a conventional classroom, students will not have so much interest. Probably they will be even sleeping. Let us consider driver for problem-based learning in India. It is a Make in India. This is the important aspect with respect to engineering education. Let us see how it is going to affect. Design in India, develop prototypes in India, test in India, prove the products in India, improve the products, mass produce in India, export from India, innovate in India. These are things go with our engineering education. When they say that make in India, we have to consider every other aspects in our classroom discussion and also make the student go to that level. Let us consider next aspect, students' behavior. This is nothing but students' behavior progressively mirrors that of the faculty. Both the teachers and students are learning the new situations in undefined cases. If you really consider, this is the type of problem we get from the government, from public, from the field, information deficiency. All these problems will have to be considered for any engineering project design, all these things. Let us see problem-based learning. Active and student-directed, peer and tutor monitored. Should have completed core and applied courses. Learning in the context. Assist students to organize their long-term memory for retrievals. Communication skills. Respect for the views of the others. The critical skills. The satisfaction of contributing to the group. Ability to give and take criticism without offensive being cast. Let us see the motivational learners. The excitement for self-study. Assume the role of future executives of companies. Realize the importance of excellent solutions. Learn project management. Aid in executive development. Let us see the problem in the shop floor. And also the self-directed learning of the students. Self-directed learning really centers around self-assessment, developing the learning habit, learn problem analysis, improve critical thinking. Let us have a definition for a problem-based learning. The pedagogical strategy for posing significant contextualized real-world situations and improving resources, guidance, and instruction to learners as they develop content knowledge and problem solving skills. This is given by Mayo and others. Let us see the problem-based learning. New ranking. Learner's role. The students what they are supposed to do. In problem-based learning, students collaborate to study the issues of a problem or they try to create visible solutions. Learning in problem-based situation normally occurs within small discussion groups of students facilitated by the instructor or faculty. Let us see the faculty role. Faculty member becomes a subject matter expert, resource guide, task group consultant, encouraging learner participation, provides appropriate information, assumes the role of fellow learner, avoids negative feedback. This is the most important thing. Let us not give any negative feedback to any group or any student. So let's see the advantage of problem-based learning. Task group process information. There is a group of students, when they take the case, they are going to do that. Competency to solve the problem they must have. Develops flexibility, develop cognitive strategies, helps to analyze unanticipated and ill-structured situations, produces meaningful solutions. Let us see the conventional lecture method. Information on knowledge and rules given by the faculty, situation specific with well-defined problem parameters, predetermined outcomes with one correct answer, focus on instruction is to solve predetermined problem, generally does not prepare the learners to solve real-life complicated problems, ineffective in transferring learning to new domains or to the field. This is the conventional lecture we already saw. Let us consider real-life problem. Seldom parallel to well-structured problem. Demand critical thinking skills. Learning need to interact with life beyond curriculum. What we say, two ends of the curriculum. Number two, class, maybe 4 walls of the classroom. Meeting hours, maybe 3 hours in the morning, 3 hours in the evening. Demand for a problem solving skills, as you see. Let us say the real life problem. Problem based learning is concerned with what should students learn, how they should learn. Let us see specially prepared problems, usually written cases derived from real world experience. Can be from a design, can be from a performance of an engine, or settlement of a building, or settlement of a bridge, or whatever the case. Stimulate active learning based on the learning outcome. Integrated approach, science, engineering, mathematics, management, all other things, students have to think and start using it. Let us see the implementation of problem-based learning. As faculty members, we have less lecturing, more learner contact, self-directed learning, relevant materials. It's based on the practical applications, clearly related to the objectives for teaching. Let us see the implementation of program-based learning. The focus of problem-based learning, it encourages the learners to work on real-life problems, integrate experiences, recall previous knowledge, networks, skills, and procedures. Let us see the problem-based learning steps. Clarify terms and concepts which are not clear. Define the problem. Analyze the problem. Brainstorm. List possible outcomes. Formulate program learning objectives and set priorities. Look for additional information outside the group. Report back, synthesize, and test the decisions. Let us see the speciality of problem-based learning. Places the responsibility for the learning in the hands of the students. Very useful teaching strategy for senior undergraduate programs, something like the 3rd year and 4th year students, or maybe 7th and 8th semester. Provides exposure to the learning in the product development, good starting point for shared learning. Learning from case analysis of material seen by learners themselves. Uses videotapes wherever required. Let us see the highlights of problem-based learning. Students learn by analyzing the given problem. Students work in tutorial group or small group, recording key areas of learning. Learning is active and student directed. Self-directed learning skills are developed and enhanced. Teachers guide and facilitate rather than directing them. Discovery and application of knowledge emphasized over recall. Let us see the assessment. Assessment focuses on interaction of test results, reasoning, self-directed learning, as well as recognition of the facts. Let us see the assumption of problem-based learning. Students are assumed to be better able to learn and recall information through activation of prior knowledge, what they learned in their first, second semester or other subjects, elaboration of newly acquired knowledge, contextual knowledge, what is required to solve the problem. Let us see the learning process. Preliminary discussions in small groups, maybe 3 or 4 or 5 depending on the class size. Students mobilize available knowledge, what they learned in various courses, they put together. Construct explanatory models based on prior knowledge. Process and comprehends new information. Let us see the elaboration, construction of cognitive models. The discussion, note-taking, answering the questions among themselves. New information is understood if the students are stimulated to elaborate on it. Facilitating student learning, use tutorial discussion groups, small groups. Supplement by tutorial methods to stimulate active learning on the part of students. Choose problems by deriving from clear objectives, planned course outcomes. Problems are sensitive to the level of sophistication at the different stages of training. What they can do in the first year is different from what they are supposed to do in the 4th year or 8th semester. Let us see the traditional approach. There will be a lot of curriculum overload. Inappropriate teaching methods are used. Shifted emphasis of real life, undefined, away from interrelated disciplines like mathematics, material science, and technology. Let us see the implication of problem-based learning. As I said earlier, less lecturing, more student contact, small group, self-directed learning. The students started thinking they already entered to the field, the problems given to them. They feel they're all engineers, they can really solve. If the group of 5 or 6 are going to sit, each one going to put a question, then they will get the answer. Finally, it is the right answer. Let us see the advantage of problem-based learning. Preliminary discussion small groups, not more than 9 at any time. Activation prior knowledge. Whatever they studied in the first semester, second semester, maybe up to 7th semester, they can bring it. Elaboration of new knowledge and also contextual learning with respect to given project or program. Let us see the general problem solving, task dependent skills. A task or challenge as a source of learning. Suppose in a foundation engineering, we give different types of soil with all details and give a building which is settled. Now they have to analyze what is really happening. Task challenge as a source of learning. Ability to assess technicians, skilled workers, solve that problem. Acquisition of knowledge exposed to real life engineering problem. That means you are taking the students away from the class, put them in the real life, maybe in the design office or execution office or testing centers, that to really see that. Problem solving skills depends on acquisition of knowledge. Let us see the learning task of problem or learning task. The group's task is to evaluate and define the different aspects of the problem, physical, social, managerial, environmental, etc. Achieve an understanding of the basic mechanisms involved. A planned strategy, a way of enabling students to develop acquired reasoning and critical thinking more efficiently. Speeding up the process of acquiring the experience. Integration of basic science concepts into field problems. Focusing on application of previous knowledge in new situations. Encourage the integration of knowledge from domains, mathematics, physical sciences, even engineering, material sciences, or even construction. Students are able to integrate basic knowledge, core and applied knowledge into the solution of different field problems. This core is nothing but what we teach before they enter into advanced courses. Let us see the desired learning outcomes. An ability to function in a multidisciplinary teams, especially once they leave the college. Most of them will be working in teams, group of 5 or 10 or 20 engineers to solve a problem. So they have to really learn how to work in the multidisciplinary teams also. An ability to identify, formulate, and solve engineering problems. An understanding of the professional and ethical responsibility. An ability to communicate effectively. Let us see the desired learning outcomes. What really, when we think about problem-based learning, it really goes around program educational objectives and course outcomes. So the broad education necessary to understand the impact of engineering solutions in a global, economic, environmental, and social context. Recognition of the need for and an ability to engage in lifelong learning. Learning goes beyond classroom, examination, till they retire, or even at retirement, they have to keep learning. The ability to use the techniques, skills, modern engineering tools necessary for engineering practice. Let us consider self-directed learning skills. Learn to meet personal needs. Independent, self-directed, lifelong learners, self-evaluators, conduct literature researches themselves. Let us see the intrinsic interest in subject matter. Enhances intrinsic interest in subject matter, increases motivation, involves learners to more actively in the issues at hand. Let us see the potential difficulties with problem-based learning. The variation quality of the faculty members or teachers, tutorial skills, confusion among the students, lack of a sense of purpose, orienting and training the students, seminars or lab demonstrations are essential. Let us see competency list for faculty, knowledge of program educational objectives, conduct of job analysis, rules the tasks to be accomplished, prepare competencies list, grade them, write learning objectives and learning outcomes, select appropriate real-life problems, maybe from field situations, industries, or whatever that comes in newspaper, convert them into a problem. Let us see the competencies. First is the development of cases. Based on the program educational objectives and course outcome, cases are to be written from real-life observation. Small groups are to be formed, guidance are to be provided for learning material, brainstorming to be conducted, feedback, moderation from the tutor or faculty. Whenever write the case, we will not reveal the members who are involved in the real-life situation. Let us see the checklist for better learning. Agree on your mission. Create goals for student outcomes and process. Identify related activities for each goal. Brainstorm appropriate measures. Evaluate and select measures. Identify appropriate assessment methods. Develop a plan for collecting data. Prioritize goals. Set timeline, milestones. Implement assessment plan. Use data to improve processes. Communicate results. Let us review the cases, what we call formative evaluation. We have to sometimes use interdisciplinary approach. We have to edit it, preparation of data and information materials, prepare video clippings wherever required. Let us see the assessment of learning. It begins with the educational values, should reflect on understanding as multi-dimensional, integrated, and revealed in performance over time. Should have clear, explicitly stated purpose. Should focus on experiences that lead to planned outcomes. It should also be ongoing, not episodic. Especially such program we have to bring series of cases, maybe the design of foundation, construction of the superstructure, maybe problem due to earthquake, problem due to climate change, problem due to floods, all the things. So we have to look into every different field problem. Should foster wider improvement when representatives from across educational community are involved. Begin with issues of use and illuminate questions that people really care about. We should be a part of larger set of conditions that promote change. Educators must meet responsibilities to students and the public. Summative evaluation, what we do after the completion of this particular set of exercises, we have to really review the findings of the students, fine-tune the case files based on the performance of the learners. We have to rewrite, modify, give additional data, give additional pictures, or we have to give a video clippings. Once this is done, we can have a library of the cases we can use in the classes. Exit interviews of the learners, get the feedback on the implementation of problem-based learning, review and improve. Once we complete set of courses, then we can get the feedback from the students what they feel about the methodology. Smart students, yes. Thank you. Your questions, please. Now I think members can put the question so that I will be able to answer. And also you can send the question to my email ID. I can also provide answers. Thank you very much.
One of the participants asked, have you practiced this in a college?
Yes, sir. Please, little more louder, please.
Have you practiced this in a college?
Yes, sir. I practice in a number of teacher training situations, practice in MTech HRD program, practice in a number of undergraduate courses. Really, I feel once you give the case study method, problem-based learning, students really feel very happy. Even many management cases given for management programs with MTech HRD, I feel it's really successful one. The most important thing, we must really prepare the cases very well. It should be based on the what we teach, and also it should really reflect what they're supposed to do after getting the degree and working situation. It is little bit tough initially, but once you start doing, then you'll be able to prepare the cases what is required for the students. There will not be any difficulty. Only thing is, if you consider medical education, the strength of the doctor depends on how they diagnose a case in the real life situation. Similarly, in the case of legal education, probably they learn more by analyzing the core decisions and the cases, all the things. In engineering, we have to really bring this problem-based learning in a better way, so the students really prepare to solve tough problem situation.
What are the steps to be taken by universities?
In the case of universities, they must give more autonomy, especially in the final year subjects when you have a project method. In addition to that, they must also provide certain amount of basic cases in all subjects, provide a case studies and then circulate to the faculty, train the faculty. Then we can improve the classroom situation, give the cases, then we can guide the student to solve, and also we can really understand the maturity increases. What is required, especially the Western universities, when there is autonomy, the faculty members come to the class with a video clipping and questionnaires, and students are asked to sit in the group. They give the questions, they solve and give. Sometimes the case itself is so tough, they have to make analysis and say, then they do that. Because undergone 3 or 4 courses where this case study method is completely used, problem-based learning. At the end of the thing, people really feel, even after 30 years, yes, I discussed like that, my friend said like that, this is the point, This is the way the faculty gave the solution. We never forget what is done in the class. It's the best method.
Please differentiate between project-based and problem-based learning.
In the case of problem-based or project-based, it's slightly different. In the case of project-based, we have to think about the outcome and work backward, and we can really think of how each step we are going to design, develop, complete, test, and then hand over it. In the case of problem-based, it is slightly smaller than the full-fledged project-based method. This only we take a small problem, goes with the curriculum, and then we do that. I will give a small example with respect to settlement of building. I am basically a civil engineer. Suppose when we teach soil mechanics, we teach everything. But when we take regional deposits, we rarely give complete information. Suppose a building is settled, then we have to bring the case studies, the settlement, the time duration, and also soil data. And we'll give to the students why this particular soil is behaving like that. What is the bearing capacity? What is the settlement that taking place? Will you settle more? Can we think of some other method? Then what could be the best method? So we have to really think of some tough field situations. Uh, Problems in Chennai, all along the sea coast. The soil is so weak. Probably even buildings started settling to an extent of 90 or 100 centimeters, 1 meter, because the soil is so poor. See, most of the structural engineers, without deep knowledge in soil mechanics, they always assume this is the bearing capacity. That should be stopped. We must have a realistic field data, do that. Once they study the case, then they will not commit the mistake. They may even call another soil engineer, give the data and do that. So this really gives a lot of responsibility for the students. The same case with the mechanical engineers, electrical engineers. We have to bring the field failures and do that. Even in the computer science, you have to bring the cases that really cause a problem to the end users, and then they will think of how to really prepare the program. So this is the best method. In my view, I got a lot of feedback from the people. They really love to take the cases. This is a challenging one. Even in the case of adult learning, field engineers, they need only this kind of method. Yes, please. Next question.
Please give an example of incorporating problem-based learning in a typical course.
Probably when you consider any project, especially the final year, when the students are ready to leave the college and they take up the work, they must have a sense of problems that are all pressing in each branch. With respect to curriculum, what they are supposed to do, we must create a problem, create the case, and also we must provide, and also they must ready to take it. If this is done, I think things will be very easy. Universities have to spend more time, maybe call number of field engineers, ask them to give the problems what they faced. Then we have to prepare, because field engineers will not have time to prepare a case study. So we have to do that. Maybe if there is another occasion, I'll prepare another complete set of program like this. How to prepare a case study, how to go with that, how exactly is different from project-based study. Project-based is total right from beginning to end. There are new methods are coming and the new knowledge is there. We can really share so that our Indian students can do extremely well in the international level. Today, I think the West is really looking at the East. The Chinese have done well, the Japanese have done well, Koreans have done well. I think we can also do very well. A small mental change is required, and also give some independence. Some kind of teamwork is required among the faculty, prepare the cases. Maybe we can conduct mini seminars for the faculty members, how to really prepare, edit, and conduct the class, so that we can really improve their visualization of this method. Is possible.
How do you design problems for PBL, say for Maxwell's equations?
Can I just request you to repeat the question again, sir?
How do you design problems for PBL, say for Maxwell's equations?
In the case of designing problem for problem-based learning, it really occurs from real-life situation, design, planning, methods, all the things. Probably we can really consider with respect to agriculture engineering. We can really see that many things can be done. Probably the advances in machinery management, power supply, and also land use. Probably we can really connect the problem so that an improvement can be brought in the minds of the students. Similarly, in the case of electrical engineering, mechanical engineering, we can really think of design method, manufacturing method, and also how exactly they can improve the productivity, how they can really reduce the wastages, how they can prevent number of accidents. Because these are the problem I gave to my postgraduate students in human resource development. They went to the industry, prepared all the things, came, discussed, and also prepared the reports. In the case of our students who are coming for teacher training, curriculum development, we just allow them to bring the problems with them. Then we prepare the method and then they started learning. Once they feel they completed the project, they go back. They're slightly at the advanced level where they are fully in charge of solving the problem due to various field situations. So we can really feel if you have started focusing on this method, we can really improve the capacity of the student to solve. This occurs mostly in the third and fourth years. Especially the last semester, we can create one subject where such problems can be designed, tested, and then distribute to the students. And also we can see how they really solve the problem. Most of the time, in my view, they'll be able to solve. That's kind of feedback I got by using these methods.
What should be the methodology accepted to engage students actively in learning?
In the case of methodology, we can really say that the cases can be given well in advance. And also we can see that this is the way in which you are going to do. In certain cases, I'll give a simple method. Probably we can use a video camera and then see how the group is developing. Initially, there will be a certain amount of uncertainty. Once somebody start the question reading this one, within 10-15 minutes, the leader will be arising out of the group. The leader will be able to put the questionnaire. Then answers will come. Finally, they will evaluate. Then they will have some 3 or 4 outcomes. A faculty member can really say that these are the 5 outcomes you got. You can ask the group to evaluate which is easy to implement, which is easy to carry out, which will really cost less, which will be give a solution immediately. So we have to really use groups to get that kind of evaluation. Sometimes once the group is giving the solution, probably other groups also can listen to that and then we can see out of the class which group is given the best solution. So a simple method can be used. We don't need anything big model. What is required is well-designed questionnaires, cases, edited, checked, and then we can have a case files we can distribute that's related to the curriculum and field. This is what we are supposed to do.
What should we do as a student to start PBL in our colleges?
In my view, most of the students are all thinking about their future career development. What is required is the fear in them should be removed. We can say that you studied maybe 8 or 10 courses in each year, something like 5 in each semester. At the end of the 7th semester, they'll have all the foundations. Now we can say that it is you who are going to be the field engineer. We are giving a problem. Initially, we have to motivate them, remove the fear, and ask them this is the thing you have to look from structural engineering, this from foundation engineering, this is on the weather condition, these are the earthquake problem, these are the standards, this is it. So just to give explanations, ask them to do that. Once they have a trouble, please go there as a friend and they tell them, please do this, read this kind of books. So in their classes, sometimes what they do, the Western system, they give some 4 or 5 textbooks connected with that so that they can refer, tables, all the things. So they take charge, something like a field situation itself. Time is given something like 2 hours for solving such a thing, and then they do this. So what is required is certain amount of understanding the students' difficulties and make them feel they are capable of solving it. We have to elevate their motivation, communication among themselves, and also capable of writing the case, history, and the study and the final report. So we must really help them a lot. Once this is done, maybe 1 or 2 classes they'll able to do very well. This is what I saw in many courses which I conducted.
Can you publish some case studies of PBL you have personally done?
Yes, sir. I prepared number of case studies in management and also in civil engineering. These are all based on the building failures, wrong decision taken by structural engineers, field people, and also insurance claims. What is the role of the department? What is the role of the contractor? Or in the case of design is done correctly, but unfortunately they didn't take care of the soil conditions. Building started. Even in my own institute in Chennai, one building settled by 90 centimeters, where a next building is standing. One is on mat foundation, other on file foundation. And also when we think about on water tank, it failed. So we are able to collect case studies like that. And also problem with respect to Rameswaram railway bridge. At the time of construction, some big hurricane came, and the contractor said department has to pay the compensation. Then finally said the court said it is not a department problem. The contract should have gone for the insurance. So here, when we mingle with the field people, collecting information, all the things we get. See, in the case of many projects completed with respect to cement industry, we are able to collect case studies from various fields because they said such a thing occurred. When we conduct a project program for sugar engineers, they said these are the problems we faced in the sugar industry. So this is what we get. See, if you really consider the number of textbooks available on building failures, they collected more than 10 such books, which use it for the students, especially teacher trainees. They really made us really felt happy. What we study in the class, what we forget, how we can really overcome the problem. A small amount of creative thinking is required in the faculty members, and also they must also ready to move from classroom to the field and then look into that. See, we must have a habit of collecting cases, either through published books or through newspapers. We have to take a scissor and cut it and paste it, and then we have to make a small research, prepare the cases for the students. Maybe when there's another occasion, I will deliberate on this in depth. Next question, please, sir.
What other pedagogical strategies work as good as this?
In the case of pedagogical strategies, first we are writing the program educational objectives, what student has to do after completion of 4 years real life situation. They have to design, they have to estimate, they have to complete, they have to supervise, they have to manage. These are things. So when we teach in small steps. Material science separately, center material separately, dynamic load factor separately, and also the foundation designs, maybe settlement, maybe bearing capacity, maybe site improvement. So we must bring various components into one single case. In the field, we really have these things together. When we teach aspect to a curriculum. At the end, we put them together. When we give a final engineering project, we are able to make the student to take a chance, think of the real problem, go to the industry, collect, come back, consult the faculty, go to the library. Same thing. In the case of postgraduate students, when we give a full-fledged research or dissertation, he has to collect the information from the field, come back to the institute, and then consult the faculty, prepare the literature review, and also propose a solution, go to the field, and discuss with the field engineers, come back, finally give a solution. Our students have done a lot of work. We took a decision, whatever they work, it should be connected with the Indian conditions field. So we always had that kind of relationship with the industries where they provided that kind of information. Students are given a raw problem which the industry wanted. At the end, the thesis has been used by them for further development. So this kind of approach, we can really plan, develop what is required is program objectives, course outcomes, methodology, collecting the field problem, editing them, putting in a particular way, not more than 10 pages, maybe giving some additional information for testing all the things, allow the students to discuss and come with an appropriate solution for that one. Then the solutions are to be discussed in the classroom. All other students really evaluate. Then they go with the confidence the solution is there. They're capable of meeting the field challenges. This is what we do. In my view, every faculty can do this. What is required is that amount of motivation, certain amount of working together, forming a small group, sometimes interdisciplinary group, one from mechanical, one from civil, one from geology, one from maybe soil mechanics, one from hydrology, hydraulics. So the problem has to be seen from different angles. Even in industrial situation I saw, when you give this kind of problem to the people coming from industry, they're able to solve. Finally, they say that we are capable of manufacturing very good materials using this. So we have to really go beyond a classroom situation, a limited experience. We make it more advanced information, maybe giving the credibility for the student that they go with the knowledge to solve the problem. We have to bring more and more real life situations in the classroom as examples, as a method, and also solution to be created by them at the end. We have to believe our students, they are really good. That's what I did, especially my teacher trainees and also my fourth grade students and grade students. They did an excellent job. Many people felt we want this kind of courses more. Maybe we have to think from this angle. I feel every college can do. There's nothing like IIT alone can do or IAC can do. Every college they follow this method. Our students can also do far better than others. Let me put a small question. How many of you tried this kind of out-of-box thinking in the classroom situation? The university is not commanding us to do this. Unless we also break, go with a new idea, then only we can do this. Any further question, please? Please feel free to question. I learned more from your questions also.
Sir, are there any resources on freeware?
Sir, will you please repeat the question because there's some problem with the...
Are there any resources on freeware?
Yes. Maybe I can say with respect to Western system, they have a number of videotapes on various cases where the tapes are put in the class, then they really understand what are the implications. Other method would be simple one. Probably you can look into Google and then start downloading some of the cases what they use. Other method will be there are number of textbooks available, especially in civil engineering. We purchase a lot in Chennai, where we have number of books on building failures, building construction methods, what they rightly, wrongly used, how the problem it came. Even in the dimensioning, when they put number 1 along with the line that is not seen, is a 16 millimeter rod. they put as a 6 mm and then building failed. Whenever they fail to understand the design of foundation with respect to machine foundation, etc., problems came. So there are a number of textbooks available, books available for the Western system. We can use it for Indian system also. So we have to really think of correctly. If you have any field project, please try to collect the information from the field people and prepare the cases. If it's a bigger project, you'll have more opportunity to get problems. It's all India problems, problems of the various cement industries, and the environmental problem, and also the training of the workers. In various fields, we are able to get more and more problems. We must have a open eye to collect.
Is it being suggested that PBL is useless for teaching theory or maths?
Sir, will you please again put the question so that I can
Is it
think
being suggested that PBL is useless for teaching theory or maths?
No, sir, no. Problem-based learning can be used even for teaching mathematics. See what we do in the normal classroom. We teach various mathematical methods. Why not give a problem? This is a problem. Please design or use an appropriate method to solve it. It can be differential equation, partial differential equation, it can be Fourier series, or it can be any other method. Or it can be something like queuing theory. See, we must really feel math is the tool for us to solve the problem. You should not be kept away learning mathematics and not thinking how to use it in engineering. Probably I can say that request all the math faculty to see what we teach in engineering, probably in electrical, mechanical, civil. What type of mathematical application we use? Why not we take this problem and also include in mathematics so that students will be really knowing if I want to do this, I can use queuing theory or differential equation, partial differential equation, or this kind of thing. So we must integrate mathematics, physics, chemistry with engineering in such a way that the math faculty or other faculty should also have a feeling for engineering. This is what I always do. In every situation, there's a room for bringing real thinking. Yeah, mathematics is a basic tool for us to develop further research. That's what I feel. I always consider math teachers, I'm sorry to say that, even when they go to canteen, all math teachers will go separate, engineering teachers will go separately. See, they must integrate. They're all the basic people who are giving real knowledge. And we must also share the experience. Even when the students giving seminars at postgraduate level, our math, physics, chemistry teachers also should sit in the hall and see what they do. So we must integrate the thinking of basic science people with engineering. This should be done.
PBL is also being done in K to 12, so why not for year 1 students?
It can be done right from the first year also. Maybe in the first year, we consider what our architects are doing, what engineers are doing. We teach you so much about bricks, material, rock, all that things. Why not you say that this is the building, how exactly use various material, why you are using, how exactly we can create a sense, a beauty, maybe strength. So it can be done right from the first year onwards. What is required is a small amount of thinking, what we ultimately do with that knowledge in engineering, how we can bring an innovation. Innovation thinking should be that. The problem-based learning, we just challenge the student to use creativity to solve the problem. Whatever they learn will be used to solve real field problem. If this is done well, I don't think there will be any problem for the field people to say our engineers not up to that level. We can say that our engineers can do a much better job and also bring innovation in design, manufacturing, testing, new type of products to meet the new changing situations. Already many of our students who are in other countries, who have gone there, they have done very well, because that situation provides that amount of curiosity, that amount of situation to innovate. We must also do that. A rigid situation will not help us.
How do we encourage university and colleges in India to start problem-based learning?
Sir, whenever they ask me to give a lecture to number of situations, I conducted more than 20 or 30 such things. I brought this kind of approach. They really appreciated. Only thing I don't know whether they really put them into use. I can give one simple example. When I did our master degree in 1968-70 in IIT Madras, one American professor came. We discussed what they did our research for. Finally said, will it be of any use to Indian engineers? Why not you take a field problem and come to the institute and start working on that one, so that every research output will solve set of field problem, give that kind of knowledge. So most of the time we have to think of taking real life problem, what really occurs, and then we must guide. We can also learn along with our students. Finally we'll become a stronger people. This is what I can say. Maybe when there is another opportunity, maybe I can provide another lecture with respect to how to prepare the case, how exactly it will go with that one. Maybe I can give more cases either in management or in civil engineering, not in electrical or mechanical. Mechanical, I can provide certain examples where we did work with respect to industries. We can really say that some of the cases really gave lot of input for the industry. They are doing very well. We must also love to take up real problem where we don't have a solution. We learn along with the development. Maybe we must ready to take up a challenge. At the end, we'll be learning it. Initially, we'll be having same confusion like others. It's doing research, thinking more, looking into the methods what other countries have done. How exactly we can bring that kind of situation in the real life. This is a challenging one.
How can PBL be directed to research?
We can say that even research method, it should be a problem taken from the field, what field engineers have failed or looking for a solution. Then we must work on that one. Especially every hour we spend in research should have more outcome which will change the field, manufacturing, development, costing, quality, capable of understanding that one. So this goes up to that. Even at doctoral level, we must take that kind of challenging problem where we'll able to innovate and more.
Thank you very much, sir. I will send you all the questions and the feedback in by email. And one of the participants also requesting that he wants your slides if you are willing to share them.
I'll be happy to provide more and more information if the opportunity comes. I have more than some 30-40 programs of this nature. Based on the needs, we will provide time to time. My aim is our Indian faculty members are superior to any other faculty members in any other country. If you provide an opportunity for them to think, become a leader, we are doing the best service to the society. Thank you very much. Thank you all.
Thank you, sir.